Good morning, class. So in this video, we're going to be talking about the discriminant, and I know that many of you learnt about the discriminant last year, so just consider this video a brief recap and refresher on the topic. So we begin by looking at our quadratic formula, and our discriminant is going to live underneath this square root, and we denote the discriminant with the symbol delta, which is a Greek letter. So if I was to say that more formally, for a quadratic equation in this form, the discriminant is given by delta equals b squared minus 4ac. Now, of what use is the discriminant? Well, to answer that question, let's go through some examples. So let's start here. So we're told here that if my discriminant is greater than 0, there are two distinct real solutions. Now, what do we mean when we say solutions? All that word means is that we're counting the amount of time my parabola touches the x-axis. Sometimes this is also referred to as roots, so you might hear we have two distinct roots or solutions, but all it really means is how many times my parabola intercepts my x-axis. So now to answer this question, I'm first going to identify what my a, b, and c value is. So my a value is 1, my b value is -4, and my c value is 3. I then could write out my discriminant, b squared minus 4ac. I then would sub in my values, so my b value is -4. Then I have 4 times a is 1, times c is 3. I then continue with my working. -4 squared is 16, minus 4 times 1 is 4, times 3 is 12. So what I'm going to get is 16 minus 12 is 4. Therefore, my discriminant is greater than 0, which means I have two distinct solutions, or to say it another way, I have two distinct places where my parabola touches my x-axis. So right here and right here. And I could prove this to myself by simply factorizing this quadratic, which is really quite simple. It will be x minus 3, x minus 1. So in this case, I'm going to get x equals 3 and 1 as my intercepts. So here will be 3 and 0, and over here will be 1 and 0. And that's simply how we do it. And therefore, when I have a discriminant being greater than 0, I'm going to have two distinct real solutions, which means it's going to touch my x-axis twice. Let's now move to my next example, which tells us that if my discriminant equals 0, there is one repeated real solution. So again, to answer this, let's begin by writing down my a value is 1, my b value is -4, and my c value is 4. I then could write out what my discriminant is, b squared minus 4ac, and then I sub in my values. I'm going to do it a bit quicker this time. -4 squared is 16, minus 4 times 1 is 4, times 4 is 16. So therefore, this time my discriminant will equal 0. And we're told that when my discriminant is equal to 0, there is one repeated real solution, which means my parabola is going to touch my x-axis only once. My parabola is going to touch my x-axis only once. And again, I could prove this to myself by factorizing this quadratic, which will be x minus 2, x minus 2. So now I could also write this as, if I so wished, x minus 2 squared. But what you can see here is that I have one intercept. I have one x-intercept, which will be x equals 2, but I kind of have it twice. If I was to set both of these equal to 0, my x-intercept will be 2 and 0. But hopefully you can now understand why we say we have one repeated real solution as opposed to two distinct real solutions. So if my discriminant was greater than 0, we had two distinct real solutions, in this case being 3 and 1. But if my discriminant is equal to 0, there is one repeated real solution, in this case 2 and 2. And it just means that I touch my x-axis once. Let's now move on to my final question, which is, If my discriminant is less than 0, there are no real solutions. There are no real solutions. So again, I would do this question by first outlining what my A, B, and C values are. So let me do that really quickly. I then would write out my discriminant. I would then sub in my values. I'm going to do it quickly again. 4 times 1 is 4, times 5 is 20. So I'm going to get my discriminant is going to equal -4. Therefore, my discriminant is less than 0. And when it's less than 0, there are no real solutions. Or to say it another way, there are no places where my parabola touches the x-axis. So hopefully this video has been useful to you. When the discriminant is less than 0, there are no real solutions. When it is equal to 0, there is one repeated real solution. And when it is greater than 0, there are two distinct real solutions. And my discriminant is located underneath the square root in my quadratic formula. Hopefully this video was helpful to you.